Episode 59, titled Harden Logging and SIEM Practices, we elevate logs from background noise to trustworthy sources of detection and evidence. Strong logging is not about hoarding events. It is about capturing the right signals with enough fidelity to reconstruct what happened and to stop what should not happen. When logs are complete, consistent, and protected, they become the backbone of investigations, the early warning system for misuse, and the proof set behind risk decisions. This episode focuses on the operational craft that turns raw event streams into a dependable control. Define what must be covered, centralize and normalize it, protect it like any other high-value data, and build detections that surface abuse patterns without burying analysts in alarms. If we get this right, logs stop being a cost and start acting like a force multiplier. Coverage comes first because a partial view can be worse than no view at all. Define the surfaces you must see across hosts, applications, identities, and the network, and do it in the language of your inventory so gaps are measurable. Host coverage means operating system events, service starts and stops, package changes, and local authentication outcomes. Application coverage means business transactions, error conditions with stack context, and security-relevant state changes such as access decisions and policy evaluations. Identity coverage means sign-ins, token minting, privilege grants, role changes, and session terminations tied to an authoritative user or service account record. Network coverage means flow-level visibility, segmentation enforcement results, and traffic that crosses trust boundaries. When you treat these domains as one coverage model tied to real assets and owners, you can audit the map and fill missing squares intentionally rather than discovering them during incidents. Centralization and normalization are the next steps that turn scattered events into a coherent timeline. Centralization ensures that every chosen source forwards to a single place for retention and analysis, and that buffering and back pressure are handled so bursts do not silently drop what matters most. Normalization gives each event a predictable shape. Consistent fields for actor, action, target, result, and timestamp. Consistent encodings for identifiers, and consistent time zones with a declared clock source. The Security Information and Event Management (SIEM) platform then correlates across sources by matching those normalized fields rather than guessing. A small discipline, using the same user key across identity, application, and operating system layers, lets queries travel from an alert to the causative action in seconds. Without normalization, analysts spend their energy translating. With it, they spend their energy interpreting. Protection of logs is non-negotiable because attackers target evidence as aggressively as they target data. Treat log stores like crown jewels. Use integrity controls such as append-only storage, hashing, and write-once retention features that make retroactive edits detectable. Restrict access on a need-to-know basis. Separate administrative roles from investigative roles. And ensure that attempts to access or modify logs are themselves logged and monitored. Define retention timelines that satisfy regulatory obligations and investigative needs. And make deletion a controlled, auditable action with approvals and waiting periods. Encrypt data in transit and at rest, and rotate keys with documented procedures. When you can prove that logs are complete, tamper-evident, and preserved under policy, your entire detection and response program gains credibility with both leadership and assessors. Detections must reflect real abuse patterns and business risk, not just a catalog of signatures. Build rules that surface privilege misuse, segmentation bypass attempts, and exfiltration behaviors tied to your environment's norms. Privilege misuse detections should watch for unusual role escalations, token minting from atypical locations, and high-risk actions immediately following access grants. Segmentation bypass detections should correlate denied flows, sudden allow list changes, and lateral traversal attempts across zones that should never communicate directly. Exfiltration rules should track anomalous egress volumes, unusual destinations, protocol mismatches, and patterns where data access events precede outbound spikes. Each rule must declare context and suppression logic so it fires when it matters and stays quiet when it does not. Good rules speak the organization's dialect. They are specific enough to be trusted and general enough to catch unknown routes to the same harm. A typical pitfall is alert noise that drowns analysts and hides anomalies in plain sight. Noise grows from uncalibrated thresholds, duplicate rules that describe the same behavior, or rules that fire on common administrative tasks. The result is fatigue and missed signals. The remedy begins with ruthless measurement. Track alert volumes per rule, false positive rates per week, median time to triage, and the fraction of alerts that lead to tickets. Deactivate or merge rules that deliver little value, and set caps that page a human only when a pattern crosses both risk and rarity thresholds. Build quiet hours policies for known maintenance windows so you do not train teams to ignore alarms. When noise falls, sensitivity can rise without wrecking morale. A quick improvement that changes outcomes fast is tuning thresholds using baselines and feedback loops. Establish baselines per system, environment, and user cohort for events like login velocity, data export volumes, or configuration changes, and teach the SIEM to alert on deviations measured against those local norms rather than global absolutes. Pair every detection with a feedback loop in the ticketing system, where analysts mark outcomes true positive, false positive, or needs rule change, and feed that label back into rule tuning on a fixed cadence. Add explain notes that capture why a rule fired and why it was capped or tuned out so future analysts inherit decisions rather than rediscover them. This small discipline turns the detection layer into a learning system guided by real operations, not guesswork. Consider a practical example that illustrates why tuning and workflow matter. A token anomaly appears. A privileged service account mints tokens from two distant geolocations within minutes, a pattern that the baseline model flags as improbable. The rule triggers a standard playbook. The session is terminated programmatically, an immediate password and key rotation is initiated for the account, and access logs for the preceding hour are gathered automatically. The incident channel posts a concise packet actor, times, sources, impacted services, and recommended containment steps, and opens a ticket with the integrated replication steps for verification. Within minutes, the on-call engineer validates that one source is legitimate maintenance and the other is an unexpected location tied to a misconfigured jump box. The fix is applied, the rule gains a suppression note for planned maintenance tags, and the evidence is preserved for audit with hashes and timestamps. The cycle is short, controlled, and well documented. Link the SIEM to incident workflows so detection becomes owned action rather than a blinking light. Every alert of defined severity should open or update a ticket automatically, assign an owner, set a due time based on risk, and populate replication steps and evidence links. On-call rotations must be visible and current so the right person receives the alert, and escalation chains must be unambiguous when a threshold is missed. Integrating the SIEM with collaboration channels, runbooks, and change records lets responders see signals in context, whether the spike is an attack, a new deployment, or a known test. When detection, ticketing, and on-call practices are wired together, the organization stops debating who should do what and instead moves directly to what was done and where is the proof. Regular log reviews are the preventative care that keeps the system honest. Schedule recurring checks for completeness by reconciling expected sources against actual ingestion, for drift by comparing field schemas and time synchronization health, and for blind spots by scanning for assets with no recent events. Inspect parsing errors, dropped events, and sudden volume shifts that might indicate misconfigured agents or disabled logging. Validate that time zones and clock references remain aligned so cross-system timelines still make sense. Record these reviews as short memos with findings, fixes, and owners. Over time, these memos become evidence that logging is a managed control, not a lucky accident. Safeguarding privacy must be designed into logging so detection power does not become data risk. Minimize sensitive data fields and avoid storing raw personal data when derived indicators suffice for detection. Mask or tokenize identifiers where possible, especially in application logs that might otherwise collect payloads. Apply data classification tags to events so retention and access policies can enforce stricter rules for more sensitive categories. Document consent or lawful basis where applicable, and ensure exports to lower trust environments strip unnecessary fields. Privacy by design does not weaken detection. It strengthens trust and reduces the harm radius if a log store is ever exposed. Documentation closes the loop by making retention, deletion, and export procedures predictable and auditable. Write down how long each log class is kept, how deletion requests are authorized and executed, and how exports are packaged and transferred. Sign archived bundles. include manifests with hashes, and record who accessed them and when. For external reviews, prepare a concise overview that links policy statements to operational evidence, screenshots of retention settings, access control lists, and deletion job logs with timestamps. When auditors or authorizing officials ask for proof, you can answer in minutes with a coherent bundle rather than reconstructing decisions from memory. A simple memory anchor helps teams keep priorities straight under pressure. Collect broadly, protect strongly, alert wisely. Collect broadly means cover all tiers that matter: host, application, identity, and network tied to the inventory. Protect strongly means treat logs like sensitive data with integrity and access controls and clear retention. Alert wisely means tune rules to real risk and keep feedback loops tight so signal quality improves every month. Say the phrase at stand-ups and reviews until it becomes the reflex that guides both design and daily operations. Culture is built on repeated, shared shorthand. In conclusion, hardening logging and SIEM practices is the quiet work that makes every other security control more effective. With defined coverage, normalized streams, protected stores, focused detections, disciplined reviews, and privacy-conscious handling, logs become both an early warning system and an unimpeachable evidence trail. The immediate next action is practical and energizing. Run a rule tuning session. Bring recent alert metrics, baseline comparisons, analyst feedback, and a small set of high-value rules to refine. Adjust thresholds, merge duplicates, add suppression logic for planned changes, and document what you changed and why. Each tuning session buys back analyst time, raises signal quality, and moves the organization closer to trustworthy, repeatable detection. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.